So I'm Peyton Wassmiller, and my lab group is McKenna Berryhill, Joseph Ray, and I, again, Peyton Wassmiller. And we did comparison of photosynthetic compounds in different oak leaves via HPLC. Chlorophylls and carotenoids are really prevalent in biological organisms. Chlorophyll is any of the green pigments found in plants and cyanobacteria that allows for photosynthesis, and they absorb strongly in the blue and red portions of the magnetic spectrum. They're generally defined by a presence of a fifth ring beyond the four pyrrole-like rings. Most chlorophylls are classified as chlorines, which are reduced relatives of polyolefins found in hemoglobin. Carotenoids are similarly important. They absorb light energy for photosynthesis in a lot of plants. They range in colors from pale yellow to deep red, and thus the classification isn't as simple as in chlorophyll just because of the range of colors. There's over 1,100 known carotenoids, in fact. They all belong to a particular category, which is basically just the molecules consist of 40 carbons, and they're all kind of derivative of that. Their structure is highly conjugated, and it leads to a high reducing potential and allows the transfer of electrons in the molecule. Particulate packing C8 and C18 on silica columns are commonly used as well as documented for separation of pigments, 18 column. So kind of what we've come up with for separating these pigments is using obviously an HPLC unit. So we've chosen the Dionex Ultimate 3000 with a UV-Vis photodiode array detector at the end, specifically because I'm familiar with the Dionex 3000. Just some general specifications is that it can do flow rates of up to 10 milliliters a minute, and even minimum flow rates down to 300 nanoliters a minute. It can maintain pressures up to 9,000 psi, hence high pressure liquid chromatography. And we're going to use this with a PINAP bonded silica column, just based on some of the literature that we read. Our average particle size is 2.5 micron, and it works in a pH range of 2 to 7.5, which is important whenever it comes to the sample preparation. The mobile phase that we're going to be using is 1:1 acetonitrile to methanol at half a milliliter a minute. So the plant material is going to be taken from various oak leaves, white, red, and water oaks, and the leaves will be weighed out and ground in a mortar and pestle in the presence of calcium carbonate and ascorbic acid to prevent oxidation, just so you don't lose any of those pigments. A half gram of each plant material is then placed in 10 mils of methanol to extract the dyes, and the methanol will be filtered through a 0.2 micron syringe filter and placed in an auto-sampler vial. Each sample will be run in triplicate on the chromatograph immediately following the extraction, ideally. Your expected results, obviously, we all know what a chromatogram looks like. You're going to get a bunch of peaks at the beginning, and we have some listed times for expected retention times. With a PINAP column at 40 degrees C with a mobile phase of 50-50 acetonitrile to methanol, we expect a elution time of 1.4 minutes, 2.4 minutes, 5 minutes, 6 minutes for chlorophyll A, B, and carotenoids A, B, respectively. On the poster, you can see that in figure 1. The peak area of each analyte will be averaged per species, and the average will be compared across each sample. These peak areas are going to be directly related to the amount of each of those pigments present in the sample. Some expected challenges that we might have is that chlorophyll is very labile and is super sensitive to light, heat, oxygen, and chemical degradation. So during the sample preparation, you kind of got to do it as quickly as possible and in an atmosphere that is conducive to chlorophyll. Another challenge during sample preparation is that enzymatic reactions can occur during the pigment extraction process if the temperature isn't cold enough. So you have to do it in absence of light, heat, oxygen, all of this perfectly in order to get perfect results. So ideally, if we could go to lab, this is what we would do. And I do enjoy that we don't have the restrictions of the lab because we do get to pick our instrument. So in this case, again, I've chosen the Dionex Ultimate 3000 with the photodiode array detector, which I'm not sure exactly what we have in lab, but I like that I get to choose it here. Anyway,